Hello, everyone. My name is Matt Ernschwender, and I will be giving a talk on developing CTFs, writing and hosting intentionally insecure software. This talk is going to peel back the curtain a little bit on what it takes to actually host a capture the flag competition. A little bit about me. I do a lot of CTFs. I find them very fun and exciting. Most recently, I competed in Red Team Village CTF, and we placed top 15, which was a lot of fun. I also do some CTF challenge development and CTF hosting. I work with the CTF4Hire team developing challenges, and we've hosted many different CTFs. We hosted CTFityCon last year, we're hosting CTFityCon this year, and I've developed many challenges for them, and I've also hosted CTFs on my own for the student organization I am the president of at Clemson. I am a third-year computer engineering student over there, and CU Cyber does a lot of cybersecurity related stuff, not just for competitions, but it's a club based in Clemson for people who are very interested in cybersecurity. Here's a little overview on what this talk is going to be about. First, we're going to talk about what are CTFs, the different kinds of CTFs, because the different kind of CTF can vary on what the infrastructure looks like. Going to talk a little bit about what CTF infrastructure generally looks like. Then we're going to transition over to writing CTF challenges. It's mainly going to focus on taking your challenge idea, such as an SQLI or local file inclusion, and actually being able to host it and run it on a server. Then we're going to talk a little bit about the challenge and infrastructure security. This is a hacking competition, so there is a lot of security involved with running these things. After that, we'll transition to common pitfalls and good practices. These common pitfalls are a lot of people approaching me asking questions about hosting CTFs and their misconceptions they have when it comes to developing challenges, provisioning infrastructure. And the good practices are good practices, not best practices, because every time I write challenges or I host a CTF, I'm constantly learning something new. So my good practices are always changing, and I can't really say they're the best. After that, we'll go one step further and talk about ways you can improve on these ideas and make the CTF hosting more fun. So firstly, what is a capture the flag competition? The whole capture the flag idea originates from the traditional game where you have two different teams or more compete trying to steal a flag from each other's territory and delivering it to some central location or to their territory. The people over at DEF CON decided to adapt this for computers. So instead of people in some physical location trying to capture a flag from somebody else's territory, it's people on computers trying to hack into other people's computers, trying to steal some sort of flag or a file, and then delivering it to the flag verification server. There's also other CTFs. So another idea that came about is let's mix Jeopardy in this whole capture the flag competition idea. So with the Jeopardy CTF, which is the one that CTFityCon is, all of the challenges or vulnerable services you have to hack are laid out in a Jeopardy board, separated by challenge category and also the number of points that you will get for solving each challenge. Another common type of CTF is boot to root. Boot to root is the CTF you'll see on the TryHackMe platform or Hack the Box platform. This is slightly different than your Jeopardy style, where instead of attacking some individual service, you're attacking a full machine. So this involves a lot of enumeration, privilege escalation, whereas with the Jeopardy CTF, you won't really see a lot of that enumeration and privilege escalation. It's mainly whatever challenge you see. CTFs have evolved a lot over the years. Many different spin-offs to CTFs have come about. One is called the Splunk Boss of the Security Operations Center, Where with this one, instead of actually hacking into different services, you're given some sort of Splunk logs or access to a Splunk instance, and you have to go and find flags or other things in the Splunk instance. There's also King of the Hill, where instead of people attacking each other, they're attacking one central machine. HackQuest, and many others. The one thing that they all share in common is you're solving some sort of task and receiving a reward for it, which is the points. Based on the number of points you get, determines on what position on the scoreboard you'll become. Okay, so why is knowing all of the terminology and different types of CTFs important? Well, the type of hosting and the security considerations really change depending on the type of CTF you want to do. For the boot to root, you really have to keep in mind, hey, we're attacking, full-on machines. However, we need to make sure the whole network those machines on is secure. Whereas with Jeopardy style CTFs, you're only caring about the one little service or the one little challenge. Since CTFCon is a Jeopardy style, this presentation will focus on that. If you're interested in the more boot to root style or the attack defense style, there are many resources online. Okay, so that's a little bit of background on what CTFs are, what the different types of CTFs are, just to gain some common knowledge. Let's start going into the actual infrastructure. So the CTF infrastructure mainly has two sides. You have the scoreboard side and the actual challenge side. So the scoreboard is what is used to keep track of the users. It also presents the challenges to the players, and it also keeps track of login information and other scoring. Luckily for people who want to host CTFs, a lot of the scoreboard frameworks exist nowadays. So there's no need to go and develop your own website to actually host a CTF. The common frameworks that exist are CTFD, RCTF, and CTFX. They're all free and open source over on GitHub. At CTFityCon, we use CTFD, a very heavily modified version of CTFD. For people who are just starting out with CTF development, I highly recommend CTFD. It's very easy to learn and very easy to get started with. So here's a little bit about what the actual scoreboard looks like. You'll typically have some sort of web front end. So this web front end will be in charge of actually displaying the information to the user, and it will communicate with the back end, which will then communicate with the database, and the database will contain things such as the user information, team information. If a team submits a flag, the backend will be in charge of querying the database to make sure is the flag submitted actually lined up with the challenge they're submitting it for. This is why a lot of CTFs will use pre-existing frameworks, because a lot can go on just based on the scoreboard. For CTFityCon CTF, we use CTFD, as I mentioned. It's a heavily modified version of CTFD that we have integrated with Kubernetes, and we'll talk a little bit about that later on in the presentation. But CTFD is a fantastic framework, very easy to get started with. On the opposite side of the infrastructure is the backend. So the backend is what is in charge of actually hosting the challenges. A lot of challenges require some sort of website to connect to, or some sort of netcat host and port to connect to. The backend infrastructure really needs to provide good isolation between challenges. You don't want a RCE in some web app to allow somebody to leak a flag in another app, because then that would defeat the purpose of having two different challenges. Another good thing to have for a backend is an easy interface for managing these challenges. If you're writing a CTF which has 20 to 50 challenges, that's a lot of challenges to manage and a lot of things going on behind the scenes. So just having that good, easy interface to start challenges, stop challenges, and make changes is very helpful. The main thing about hosting these challenges is they They do have some sort of vulnerability in them, but you need to make sure there's no unintended vulnerability. You need to make sure that security is definitely the top priority. So this is a little overview on what the actual infrastructure is. Let's start getting into writing these challenges. There are two major types of challenges in Jeopardy CTFs. There's a networked and a static type. So the static types are your very basic challenges where you have to do pretty much nothing on the back end. There's only a file that you have to download. If you look at the OSINT challenges that we have in CTFS, there isn't even a file to download. It's just some description. This is what you would label as a static challenge. There's no software needed to actually run some sort of service. On the contrary to that, there are network challenges. So these network challenges have some form of service running on the backend infrastructure. These generally are web challenges and binary exploitation challenges. However, you're free to be creative on this, and it can be any challenge you want that needs a networked component. A lot of the times with network challenges, there's more development involved, just based on writing the actual, what I call infrastructure code, which is the code needed to run the challenge. So static challenges are very easy to develop. They can be something as basic as a hello world.txt file, so just a plain text file, to something as complicated as a full hard drive partition. You're really not limited in what type of static challenge you can create. The only limitation really would be where you're deciding to host these files. It could be some sort of Amazon S3 bucket. It could be some sort of Google Drive instance. But along with that, with static challenges, there's really no security concerns that you have to keep in mind, which is really a great advantage. So with network challenges are the challenges which you as the player would connect to. So these can be websites, these can be TCP servers, pretty much anything which requires some sort of network component. The most common ways of hosting these network challenges are through containers or virtual machines. For CTFS, we use containers. Virtual machines are also another good option. However, we just prefer containers because it makes our life easier. The way we utilize these containers is through Docker. So Docker is a very intuitive and easy platform to learn for developing containerized applications. Docker is also great because it helps alleviate the it works my machine, where software on my machine works perfectly fine. However, I push it to the server and something doesn't work. Another great tool with Docker is Docker Compose, which provides a very intuitive way of container orchestration or managing all of these different challenges. Another great advantage of containers is that they're lighter weight than full virtual machines. They don't have to actually virtualize a full kernel or operating system. They utilize the kernel of the system, which is very, very convenient because it means you don't require as many servers. Another awesome thing about Docker is it provides easy transport of challenges. What I mean about transport of challenges is, let's say I write some form of challenge for a CTF for my friend. Well, I send them the code and say, hey, it runs with Docker, and if they know how to use Docker, they can easily run it. However, if I were to send it to someone but not put it in a not included Docker file, I would have to explain to them, hey, you have to install these dependencies, you have to run it like this, you have to make sure these ports are open. Docker just makes life a lot easier whenever you're trying to transport software. This is the basic layout of what a web challenge would look like in a Docker container. A lot of the web challenges are written in whatever web language you choose. For me, I'm familiar with Flask, so here's a Flask example. On the right picture, you'll see a basic directory structure. You have an app directory and then the Docker file. On the left, you'll see what's inside the actual Docker file. So we'll use the Alpine image, install Python, then install the requirements for the actual Flask application, and then we'll run it with Unicorn. Here's what a binary exploitation challenge would look like. So it's very similar, just installs all of the necessary files. It will use the Ubuntu base image, then it will copy in the binary file or application, copy in the flag, set some permissions to make sure people can't delete the flag or delete the file, and then run the challenge with SOCAT so that people can connect to it. A great thing about Docker, as I mentioned before, is it comes with Docker Compose. So Docker Compose is just one command which allows for easy managing of all of these challenges. As I said, if you have 20 to 50 challenges, you're going to want to find some way of doing patches, running health checks, making sure everything is running. If you need to take a challenge down, you want to make sure you take down the challenge you need to take down and not some other challenge. So here's what a basic Docker Compose file would look like. On the left, you see we just have two services. We have our Web 1 and our Linux 1. And then we have a container name, which we supplied. And then the build is a path to a Docker file. So in the web/web1, we have a Docker file in there. Along with that, you specify ports you need to expose. So for the services in Web 1, what we are doing is we're saying, hey, port 8080 inside of the Docker, inside of the container, is going to be mapped to port 50,000 on the machine. And for the binary exploitation one, port 9999 is going to be mapped to port 50,100 on the machine. Also for the binary exploitation challenge, I have added the read-only is true flag. This means that whenever the container runs, the file system will be read-only, so people can't add files or delete files. For the web application, unfortunately, with Unicorn and Flask, it requires the temp directory to be writable. So you can't really do that. However, for me personally, whenever I am hosting challenges, I highly recommend making the file system read-only whenever you can, just to limit the chances of people removing the flag. Or also, you don't want people to spam a bunch of burst shells on your container. And you also don't want people to fill up the hard drive space of your machines. That's why I always prefer to add the read-only flag. So with these challenges, you're not limited by any means necessary. The only limitation really would be if you wanted to run an actual, virtual machine. But challenges can be written in any programming language. It doesn't have to be just one programming language. It can be multiple. But really, as long as you can run your application in a Docker container, you should be able to run it. One thing to keep in mind when creating these Docker files is prioritize security. So if you noticed in the challenge examples I showed, they were running the applications as an underprivileged user. Also keep optimization in mind. If you have some challenge which is designed to be hammered by a lot of network traffic, instead of writing it in Python, which is a language which is known for being relatively slow and using a lot of resources, you might want to transition to Go. This might seem like a small little optimization. However, if you're running multiple copies of this challenge on a server, or if you have 1,000 people running their scripts at the same time, all of the short little optimizations will really add up. Another thing is testing. Make sure that if people try to abuse the challenge in any way, that you can stop them and prevent them. I know it's very common for people to take a challenge, they get code execution, and then find some way to pivot. You want to try to make sure they can't do that. Some general challenge development notes. This applies to both the networked and the static challenges. The most important thing is make sure they're actually solvable. There have been times where people will release challenges which aren't solvable. Another thing is test very thoroughly. Unintendeds aren't really that good as a challenge developer. They make it look like you really didn't spend a lot of time working on the challenge. So just make sure you test thoroughly and watch out for unintended solutions. Another thing to generally avoid is guessy challenges. So if you have some sort of web challenge which has some obscure route, you want to make sure that route is either linked somewhere on the main page or people can easily find that. Because if people have to start guessing website routes, they'll start running tools like Nikto or GoBuster, which adds a bunch of unnecessary strain on your servers and can oftentimes bring them down. Another good thing is get creative with it. You really shouldn't be limited by what a lot of people see in CTFs, such as web challenges, binary exploitation challenges. Maybe you want to write some malware reverse engineering challenges. So just keep that in mind whenever you're writing challenges. It's good to get creative with it. Keep it fresh. All right, so that's a little bit about writing the CTF challenges. Let's talk a little bit more on the security side. The one thing that I will constantly repeat throughout the rest of this presentation is never trust the player. These are words of advice for anybody developing a CTF. The main reason is you have no idea who that player is. That player can be some middle schooler who just learned Linux, or it could be some professional nation-state hacker who works for their government doing offensive security. You just don't know. Another thing is you have to keep in mind of different types of denial of service attacks. You might think that the typical distributed denial of service attack, where people flood your servers with internet traffic, is the only type of denial of service attack, but it's not. Denial of service attacks can also be people running fork bombs in your challenges, so you want to make sure that you can stop them from doing that. It could be people unzipping zip bombs on your challenges and taking up all your hard drive space. So just to keep in mind that these different types of denial of service attacks exist, and just trying to find a way to mitigate them and make sure people don't do any nefarious things. Also, keep in mind, people will try to pen test your infrastructure. Even if you say don't do it, they'll do it. So just make sure that the challenges have some way of restricting access to the infrastructure. You don't want somebody who has remote code execution on a web app to be able to query the AWS metadata and get your secret key. Not good. Bottom line is never trust the player. With the actual infrastructure security, have firewall rules in place. You don't want people to be able to access SSH at all. Oftentimes, you just want SSH to be the only type of access to these servers so that you have that security. Another thing is network restrictions. As I mentioned before, you don't want your challenge server to reach your scoreboard server. You don't want your challenge server to reach some sensitive information. Another good thing is to configure C groups. So C groups are Linux kernel mitigations that prevent stuff like fork bombing, prevent zip bombs, and prevent all of these other bad things that can happen to your server. Always separate the score from the challenges, no matter what CTF size it is. It could be 50 people, it could be 1,000 people. Just separate the scoreboard from the challenges so people can't break out of one of these challenges and gain access to the scoreboard and make them self-admin. That would be very bad. Another important thing is be up to date on the latest CVEs. So the following CVEs I listed are recent kernel exploitation privilege escalation vulnerabilities. People who if people have the capabilities in these containers to exploit one of these kernel exploitation vulnerabilities, they'll be able to become root, and they will have root access to your infrastructure, which is not a good thing at all. Another thing is prioritize security over downtime. If you find a challenge has some glaring vulnerability or some way you're hosting the challenge can affect other challenges, just take the challenge down, figure out a patch, and then bring it back up. If you can't figure out a patch, then just take it down and say, sorry, we have to take it out of the competition, just to make sure that there's no security issues. This is more for challenge security, test for abuse. If people try to run fork bombs, make sure they can't. Never give the player root. If the player is root, they can delete the flag, and that would be pretty terrible. If the challenge grants an unintended RCE, you want to make sure they're an underprivileged user. So if you have some basic challenge that's a local and file inclusion, however, they could turn that into log poisoning and get code execution. Are they going to be root on the container? Are they going to be www data? Can they further privilege escalate to root? So just make sure you have those unintended vulnerabilities sorted out. Also, as I mentioned before, is run the challenge with a read-only file system whenever possible. So that was a little bit about the challenge and infrastructure security. We're going to get into the common pitfalls I see whenever people approach me asking about hosting CTFs, and also good practices. The one thing I see, which is the most common, is there's not a lot of effort spent on planning CTFs. The first thing I always ask people when they say, hey, I want to host a CTF is, okay, what type of CTF do you want to host? And a lot of times they'll give me, oh, I want a mix of boot to root and Jeopardy. And they're not really too sure about what the whole goal is when they say CTF. So just taking that time to really clearly outline, we want this type of CTF, we need this many challenges, we're expecting this many players, really helps whenever you go into the actual development stage. Another common pitfall I see is people starting off too large. So a lot of people will say, all right, I'm going to host a CTF. This is my first ever CTF. They'll post it out publicly on CTF time, get advertising, and 1,000 people show up. And they're not prepared for 1,000 people to show up, so they have this small little AWS micro instance, and it just doesn't work out. Don't be afraid if you're a new CTF developer to start small. I personally started with about a 20-person CTF for CU Cyber, my club at Clemson. And after that, I gradually went up to 100 people, 1,000 people, and slowly just built up to these large-scale CTFs. Another thing I see is inexperience. You want to be very confident in your system administration experience, very confident in your programming experience, because a lot of that experience will really pay off when it comes to the actual competition day. I'll also see challenges go through no testing, which is kind of strange to me because you really should test these challenges, but they'll test the challenges a little bit, but they won't realize that their challenge has an unintended vulnerability, and if the challenge has an unintended vulnerability, you don't know how many players know about that vulnerability, you don't know if people are going to report it, so it's just make sure you test enough. Another thing is infrastructure accommodation. A lot of people don't really know the actual scale of what their CTF will be and how the infrastructure will behave. You might think your basic Flask application, which uses a little bit of RAM, isn't that big of a deal. However, when you put it on a server that's being hammered by 500 people, okay, how much memory does that actually take? How much memory does my server actually need? The same thing goes with other challenges. If I run these two challenges together, well, they're also going to be used by multiple people. Just making sure you can accommodate for that. Another thing goes along with testing unsolvable challenges. There have been many times where people release challenges that are not solvable. Lastly, challenge support. Having some way of reaching the organizers is needed for a CTF. If challenges go down or if flags get deleted, having someone to contact that can fix that is really great. Good practices, devote a good amount of time to preparation and testing. It's one of those things that the more you test or the more you prepare in the beginning, really the less work and less worried you have to be whenever you're hosting the CTF. Get infrastructure up ahead of time. If you're running into any issues trying to get SSL certificates or making sure that all the challenges are able to run, getting the infrastructure up ahead of time will really alleviate that. Another thing is test the challenges and make sure the flags are correct. There have been times where in our CTFs, challenges don't really match up correctly, so we have to go in and change that manually. But you don't want people who are actually solving the CTF to see a flag, but it's the wrong flag. All right, so these are some basic concepts about hosting very basic CTFs. However, you can really take this a step further. So one of the main ways of taking this a step further is automation. Automate. Your infrastructure deployment can be automated using something like Terraform or Ansible. Use Terraform to provision the virtual machines, and then use Ansible to actually install any of the software you need. Also use Ansible to set up firewall rules and make sure that everything is secure. Another thing is health checks. So for CTF, challenges will just go down, flags will go missing, things will just happen while people are solving these challenges. One great advantage I personally see is having a very intuitive solve script. So you have a solution script, which all it does is just prints out the flag if it's there, or doesn't print out the flag if it's not. The reason I encourage these intuitive solve scripts is if somebody else is testing my challenge, I don't have to tell them, hey, here's how the script works, here's what you have to do. They can just run it, and if it prints out the flag, they know that my challenge is working. Another thing you can do and build off of this intuitive solve script is build a sort of heartbeat solve script checking. So you build some sort of system which every minute will go over the challenges and check to see if they can connect and if they can get the flag. And if they don't get the flag or can't connect, maybe have it automatically redeploy the challenge. Another great automation tip is for challenge updates and patches. I've seen CTFs which have taken this straight out of the water, where they will integrate GitLab or GitHub CI into challenge updates, where all they do is they make the change to their challenge, push it to the repo, and the GitHub CI will automatically deploy those changes, which is super cool. Here's a couple of resources on ways you can do more automation. Another great important note is challenge automation. So for actually building these challenges, you want to make sure that you can easily just run some sort of script and it builds everything. This comes very handy during the CTF when you need to push updates or make changes. You can write all the code, run one command, and everything is just built. So as I've been talking a lot about Docker and how these challenges run in Docker images and Docker containers, some of you might be thinking, oh, well, Kubernetes does large-scale container organization. Yes, it does. Kubernetes is great, and it's very good at what it does. However, with Kubernetes comes the complexities. Kubernetes as a system is very complex with a lot of moving parts. And one of the things which I sort of live by is the more complex the system is, the more chances it has of breaking or containing vulnerabilities. So you just want to keep that in mind if you decide to go the Kubernetes route. There's nothing wrong with it. The CTFCon CTF this year is run through Kubernetes. You just got to be very, very cautious and know what you're doing. If you decide to follow this Kubernetes route, RCDS, which is Redpone's challenge deployment framework, is available on GitHub, along with Google's KCTF, which is Kubernetes CTF framework. Another way you can take this a step further is if you're one of those people who are very wary of Docker container escapes and you don't really trust running these challenges in Docker containers, but you also don't want to use VMs because VMs take a lot of resources, Google has developed this NSGL container. And NSGL container is really special where it allows a lot of customization on these containers based on using a lot of Linux kernel features that restrict a lot of software. All right, gonna wrap up this a little bit. As you can see, CTF hosting is a lot different than CTF competing. CTF hosting is very geared towards system administration and more DevOps side of things. The main thing with hosting CTFs is never trust the player. You just can't. Another good thing is preparation. Preparation is key, and security. Security should always be at the top of your mind whenever you're hosting these things. All right, lastly, CTF4Hire team is awesome. I would list everyone, however, I am scared I will miss somebody, but go give them a shout out in the Discord. A lot of great people to work with. I have a lot of fun with them. If you have any questions about just CTFs or hosting them, the best places to reach out to me are on Discord and Twitter. I'm mainly pretty active on Discord. Anyway, that's it for the presentation. I hope you enjoyed it.